So today I'm going to talk about the impedance of a dielectric and free space to the electromagnetic waves. So for this, let us recall Ex and Hy, and we have defined their waveform during the definition of Poynting vector or the pictorial representation of Poynting vector. So we have defined as sine 2 pi by lambda vt minus z. Here v is the velocity and here is h naught sine of 2 pi by lambda vt minus z, and wave is propagating in this way. This is electric field component, and here along this it is magnetic field component, like this. So it's like this. Say it is x-axis, it is y-axis, and say along this it is z-axis, and electric field component is moving along this way. This is the electric field vector is moving along this way. And here along this it is the magnetic field component, right? So for this case it is the Ex and it is the Hy. Also recall that del cross E is equal to minus curly by curly t, or it can be written as minus mu curly H over curly t. And if we simplify it, then it is I cross j cross k cross, it is curly over curly x, curly over curly y, curly over curly z. It is Ex, Ey and Ez, and this is equal to minus mu curly hx over curly t I cap minus mu curly hy by curly t minus mu curly hz over curly t. It is j cap and say it is k cap. So let me simplify this and also call this as equation number 1 and it as equation number 2, because I started from here. So if I do little algebra, then this equation can be written as curly E z over curly y minus curly Ey over curly z I cap plus it's I cap, let me put it here, yeah, I cap plus j cap, and along this if I operate then negative, to make it positive I will operate it along this way. So it is curly Ex over curly z minus curly Ez over curly x, right, plus k cap, it is curly Ey upon curly x minus curly Ex upon curly y. That's what I am getting, and it is equal to this one, right? So it is minus mu curly hx curly hx over curly t I cap minus mu curly hy by curly t j cap minus curly hz over curly t k cap. That's what I am getting. So that means this part is equal to this one, and this part is equal to this one, and this is equal to this one. So that means I can write down that minus mu curly hx over curly t is equal to curly Ey over curly Ez over curly y minus curly Ey over curly z, and minus mu curly hy over curly t is equal to curly Ex over curly z minus curly Ez over curly x and minus curly hz over curly t is equal to curly ey over curly x minus curly ex over curly y. That's what we are getting here. And let us recall this as equation number 3 and say this is 3.1, this is 3.2, and say this is 3.3, right? Also consider del dot b is equal to 0, and it can be written as mu del dot h is equal to 0. That implies curly hx over curly x plus curly hy over curly y plus curly hz over curly z. This is equal to 0, and let us call this as equation number 4. Now for equation 1 and 2, the derivative of ex and hy are 0 with respect to x and y, because ex basically is a function of z and t, and similarly hy is function of z and t, right? So if these are the functions of z and t, that means their derivative with respect to x, that is curly ex over curly x, must be equal to 0, and curly ex over curly y is also equal to 0. Similarly, with the derivative of hy with respect to x is also 0, and curly hy with respect to y is also equal to 0, right? This is the thing which we have to keep in mind. So if I put their values in equation 3.3, so from equation 3.3 I can write down that because mu curly hz over curly t, which we have written as curly ey over is equal to curly ey over curly x minus curly ex over curly y. Since we have only this component, we have considered motion along this way, so that means we are not having ey component. So that means if this component is not there, then this is also equal to 0, and this part is also equal to 0. If I use its value from here, this is also equal to 0. So therefore I can write down this as that minus mu curly hz over curly t is equal to 0. So also from equation 4 I can write down curly hz over curly z is equal to 0, because these two parts also become 0. This is also equal to 0, this is also equal to 0. So that means for this part to be 0, this is also equal to 0, right? So that's what we are getting from here. Now let us have a look at another equation that we know that mu from equation 3.2 curly hy over curly t is equal to curly ex upon curly z minus curly ez over curly x. So since we have only variation in x, so that means this part is equal to 0. So therefore I can write down mu curly hy over curly t is equal to curly ex over curly z, and let us call this as equation number 5. So now curly hy over curly t this part can be written as curly over curly t. Hy I have taken as h naught sine of 2 pi by lambda vt minus z, and if I take its derivative with respect to t, then this value will be written as h naught sine of 2 pi by lambda vt minus z. And it's again derivative, and if I take its derivative with respect to t, then it can be written as 2 pi by lambda into v, right? So that means it is 2 pi by lambda v h naught sine of 2 pi by lambda vt minus z. So it can be written as 2 pi by lambda v into hy, and similarly I can calculate curly ex over curly z. So it is curly over curly z e naught sine of 2 pi by lambda vt minus z. So if I take its derivative, then its derivative can be written as e naught sine of 2 pi by lambda vt minus z into minus 2 pi by lambda. So it is minus e naught sine of 2 pi by lambda, 2 pi by lambda will be here, it is 2 pi by lambda vt minus z. So it is minus 2 pi by lambda e x, right? So if I put these values in equation number 5, so then if I put these values, this is the equation number 5. So if I put these values, then what will happen? It is minus mu 2 pi by lambda into phy is equal to minus 2 pi by lambda ex. This 2 pi by lambda will cancel out, this negative sign will cancel out. So it can be written as mu bhy is equal to ex, right? Therefore ex upon hy can be written as mu v. This can be written as mu v. Also we know that for a medium that v is equal to 1 over mu epsilon under the root. This is the definition of velocity of waves. So that means ex upon hy can be written as mu over mu epsilon under the root, and this after simplification will become mu over epsilon whole under the root. Also if I put their values, because its value will be ex is basically e naught sine of 2 pi y of lambda vt minus z, and here it is hy sine of 2 pi by lambda it is Vt minus Z is equal to mu over epsilon under the root, and this part will cancel out with it. So therefore I can write down that E naught over H naught, sorry, naught will be here, is equal to mu over epsilon under the root. So if I club these two, then I can write down this Ex over Hy is equal to mu over epsilon and E naught over H naught, right? Now let us try to understand what this quantity will represent. So as we know that this mu is equal to N over ampere square, it is its unit, and epsilon is basically Coulomb square Newton meter square. So if I try to look at the unit of this, then its unit will be like this, means Newton ampere square upon C square over Newton meter square whole under the root N over a square into Newton meter square over Coulomb square whole under the root. So it will become Newton square meter square over a square and C square whole under the root. So it is Newton meter ampere Coulomb, sorry, no root will be there, but as I know that V over M is equal to N by C, so therefore V is equal to Nm over C. So Nm over C, this is V over A, volt over ampere. So, and volt over ampere is equal to nothing but it is the ohm, right? So means mu over epsilon whole under the root, it is the unit of either I can say that resistance, but here I am talking about the this electromagnetic wave, so it has capacitance and also a inductance, because both electric and magnetic field are changing. So because of that I can say that it's not a resistance but it is the impedance, as we have talked in case of inductor and the capacitor, right? So it is basically the unit of impedance, and that's why this quantity is known as the characteristic impedance, right? So let me summarize it. So if I summarize it, then I can say that Ex upon Hy is equal to mu over epsilon is equal to E naught over H naught, has the unit of ohm. So therefore mu over epsilon represent the characteristic impedance of medium to EM wave or electromagnetic wave. And if I try to find it out for the free space, then Ex over Hy, it can be written as mu naught epsilon naught under the root, and if I put their values, 4 pi into 10 raised to the power minus 7 over 8.85 into 10 raised to the power minus 12, and its unit will be ohm, as I discussed here. So if I put their values, then this will be equal to 141,992.8883 whole under the root ohm. So its value will be equal to 376.8 ohm, or nearly equal to 377 ohm. So therefore for free space has, I can say that free space has 377 ohm as a characteristic impedance, and this is a very important point also from the examination point of view, right? So That's all for today's lecture.